That's why I did not confirm yet. So let me discuss this issue now. Before discussing the midterm, I need you to know that I'm correcting lab 3 at the moment. You should receive it soon. Some students did receive lab 3 and a lot did not receive it yet, all right? So I'm actually correcting through sections. So you need to know that my Tuesday section as well. Okay, so concerning the midterm, no, it's not going to happen this Saturday. So the tentative date was Saturday, March 20 at 10. They're asking for a change in date for many reasons. And the most important reason for other section is the following, related to Respondus and Excel. Since we have to use Respondus, it's in the syllabus, we cannot use Excel anymore, which means 3 things. We need to make sure you guys know how to find the RMS value using a calculator, which is not a big deal because you've been doing it from the calculator, not from Excel. You need to know how to find the slope using a calculator, which could be a big deal for some of you, but I don't see why not. It's not time consuming. It's the same exact thing. 3, my issue is error on the slope would be time consuming for you if it's not using the linest function, which should be taken into account in the midterm, either not give you the error on the slope at all, or simply give you enough time to be able to do it. And for other issues, I think you will be fine, okay? So for other sections who never knew how to calculate the error on the slope, or maybe probably the slope, because the slope is the big thing, they asked for extra time, and I don't see why not, especially that all my Tuesday section are a bit behind. They're not done with lab 5, and I think they will submit their lab 5 by Wednesday. So a little, they're short in time. I know that you are okay with the timing, but not the Tuesday section. So this is what will happen, which means I'm going to send you another email as a tentative timing, and you're going to reply to it, okay? I'm sorry for that. I hate it, but we are more than 6 sections and it happens. Yeah, probably, Imad, we're not going to do the error on the slope, okay? And let me tell you from now, the midterm is going to be multiple choice, which means, and if it's not, I will confirm again, but I know for a 90% sure that the midterm is going to be multiple choice. And probably you will be given around 20 questions. The timing, I don't know yet, the duration of the exam, which means if you have multiple choice, most of the questions can be answered by guessing, you know? Some of the answers would not make sense. So probably you will not need to do all the calculation, you know? Probably start with it, or probably you can guess from the values, or probably some of the answers will not make sense because the rounding is wrong. Okay, so I don't see a lot of analysis, like heavy analysis, but I see a lot of conceptual understanding, like how things vary, you know? Removing the Excel part. What do you mean removing the Excel part? The Excel part is always there. You need it for your lab report. I would say in the midterm, you cannot use Excel because of Respondus. This is what I'm saying. So we cannot ask you to plot. Yes, in the midterm, you cannot use Excel. Yes. All right. I'm not sorry for that. It's not nice, I know, but I'm not sorry for that because it's great, you know, you have Excel for the midterm. And I think the lab reports, and I think the lab reports are time consuming without it. Now for the midterm, multiple choice, conceptual understanding, fair enough. Okay. So now you know. I did not inform you yet through an announcement. So now you know, probably inform you through an announcement for the students who cannot make it to our session. All right, so Karel, I will send tonight, I believe, an email for everyone to say, how about midterm happening on March 27, which is not this Saturday, the Saturday after. The other sections are requesting 2 p.m. and not 10 a.m. Yes, Karel, please tell me about it. Can you please elaborate about your sad face and the no? You have another exam happening.
Yes, we have a midterm on 26.
It's okay. It's okay. We have no choice. And you have a physics test as well on the 27th.
I think it's good. بابا بناخد رأي الصف بس إنه إذا عملناه on 27 دكتور الصبح نعمل الساعة 10 على بكير مش نقعد على الدور بيروح وقتنا كله.
إيه بعرف. هو actually ليه كنا بدنا ننقله لل 2 p.m. because حدا كان عنده exam at 10. No, at 10. Yes, at 10. Okay. Do you have a suggestion I can give for the other sections? We cannot keep it on the 20 because they want one extra week. You think I should push for keeping it for the 20th? Let me write it down, you guys. This is crazy. So,
Doctor, maybe you keep it on the 20th and you remove lab 7 if they haven't finished it yet.
It's not up to my sections. My sections, you know, nobody said no. Nobody objected. Okay, you want us to keep it 20. How about on the 20th, but at 2 p.m. instead of 10 p.m. because some students cannot make it at 10.
It was supposed to be at 10 p.m. or 10
a.m. a.m.
Oh.
All right, Sarah. Okay, and for the students who have MUN, you will have a special arrangement. That's a different issue. All right, and if we're gonna do it on the 27th, it's impossible, I suppose. Or if it's like death sentence for you and it's gonna happen on the 27th, you would rather have it at 10 a.m. شو قلت عماد؟
لا أنا برأيي دكتور إنه لأن الفيزيكس لاب مش عامل بس إنه 4 ريبورتس للمدير أو أكثر.
إيه بس 4 اللي هن 1 2 3 5.
هي بس 4 ريبورتس عنا مش أخبار فبناخد رأي الصف بس إنه هن بس 4 يعني مش مثل كم توقفوا عنا 6 ريبورتس ندرسهم يعني.
إيه كله ما بتخيل بدكم تدرسوا يعني إذا عم تعملوا لاب ريبورتس مزبوط ما مش خرج تدرسوا للفيزيكس لاب. Just make sure you need to how to do some stuff on your calculator. Go over the lab reports quickly يعني I can see it in 20 minutes. Okay, so people, I'm gonna push for 20 again. Okay, ده نخلص منه. Okay, so I will get back to you for this one. Thank you for your feedback. Any questions related to lab 7? The lab 7 related to the buoyant force.
Doctor, it's due on Wednesday.
I think so. The best way for you to know is to check the announcements. By the way, the announcements are always there. Let me see. Announcements, it's here. So you have them ready, no? Okay, what does it say? It says that Wednesday, March 17th at 11 p.m., okay? When you ask me, I usually cannot answer this question because it's different for different sections. So I cannot remember. The only way for me to know is to go back to the announcements. If you don't have an announcement section, and I doubt, you can find it in your email, okay? Any other questions related to lab 7, buoyant force?
I have a question regarding the derivative, but I'm not sure if you want me to leave the question till the end of the session so we can...
For lab 7?
Now?
Is it lab 7? Of course, let's do that. But I want to say something for Imad before you start, Eli. You think it's a good idea to do it after biolab? Okay. Okay. I'm thinking of an alternative after biolab, but not Saturday, like the next Monday, which would be 28, 29, Monday evening.
I think it's good كان نروح ناخد رأي الصف. بس أنا ما عندنا شيء بعتقد إحنا دكتور إنه بعد البايو لاب عملنا الفيزيكس إكزام ب 7 April يمكن بس.
Priscilla, yes, I can hear you, Priscilla, but I need to tell you that other sections, they want to push the exam 1 week. All sections in Beirut and in Byblos. Monday, the 29th, late afternoon. Does it sound like hell? Nobody suggested this, by the way, and probably they will not like
انا ما عندي مشكله 29 يعني every time after 27 is good بس في section عندها كم 301 exam على ال 28 فهيدي كانت مشكلتها مع الفيزيكس ال 301
okay
كمان
28 isn't it a Sunday
مش سوري 30th يعني Tuesday the 30th عندهم كم الاكزام
في 24 hours بين 29th و 30th ما عليه
هيدي مشكلتها مع البايو لاب so basically same problem is like
ايه بس في فرق نهار مش انه بنفس النهار they need to study one day is enough to study no supposedly you're doing the work on a weekly basis knowing that physics lab ما بده درس ممنوع يكون بده درس والا ما لها طعم اللاب ريبورتس اللي عم نعمله سو نحن بنعمل لاب ريبورتس حتى ما ندرس انه we're training ourselves to for those skills and now we're assessing the skills so Andrew so far the options are 20 at 2 p.m. 27 10 a.m. 29 afternoon I don't know what time it doesn't matter after our class
ليه بتوقع على 20 شو كانت مشكلتها مع 20
all other sections they want one extra week
يعني على 27 اكيد مش ظابطه مع البايو لاب وبرايي 2 3 4 انا مني وعلي ما عندي شيء بس في ماينورتي يعني نحكي شيء 20% of students عندهم الكم اكزام بهالوقت يعني شيء 20 تلميذ بيطلعوا تقريبا بس
عندهم ايه on Tuesday
عندهم ايه on Tuesday مع لانه غير دكتور عن الباقي
yes
المشكله
so okay Priscilla I hear you I will get back to you and to be honest I don't have a solution yet okay I don't want to waste your time at the moment discussing stuff so yes I know Priscilla our mental health and your mental health is the most important thing to be honest this is what I'm fighting for okay 21 22nd I love this Monday evening I love this so you mean the 22 Monday 22nd late afternoon this is what Jane is suggesting what do you think
Yeah بحس إنه you'll please everyone إنه those that want to postpone and those that don't want to postpone it's kind of in the middle
Camp 301 on the 22nd what's that it's a midterm
exam 2 دكتور
they're right yeah I forgot about that
so it's like 29th makes more sense because the 30th ما بعرف exam 2
لا 29 make way more sense لأنه more students have it on the 22nd than on the 30th
so 29 is better than 22 and 29 is better than 27 و 20 is the best يعني فهمت صح أنا okay so I'm gonna fight for the 20 إذا بدهم alternative رح أقول لهم 29 for it not to be on the 27 to be honest they want 27 at 2 p.m. that was the alternative number 2 I'm gonna cancel this alternative and push it for the 29 now crossing my fingers it would work 20 first then 29 okay I know it's not the best thing what I can do to help you give you like a summary of the experiments you have هيك you have even to study less بقولكم this is a checklist of what you need to know هيك instead of studying for 20 minutes you will study for 10 minutes all right so I cannot see how I can push for better thing and yeah I hope Sarah you can do it يعني I don't know what to do now back to you Ellie sorry for keeping you late discussing lab 7 you said lab 7 you have a question about a derivative right lab 7
yes,
buoyant force okay so the buoyant force is here okay this what was the derivative they ask you to find the error on the slope right and then find the density the error on the density right
correct so first we got to find the error on the density
okay
and
what
the
are we
density
plotting
is the slope we got
force
the pulling force against the depth h
okay so depth and let's call it h otherwise we would think it's a density and the buoyant force is F and I need to remind myself I'm sorry for my pen being slow it's due to the recording so F is rho GV which is or density times G and Allah my pen is not writing so G, and V is basically the area, which is pi r squared times the height, right? Am I right? And height is your x-axis. So this is your x-axis, this is your y-axis, and all this is the slope. And you have the error on the slope. The question is to deduce the error on the density, right? So you say, you're gonna say that slope is equal to d whatever. So let me write it down. That's really slow. G 4 pi squared, right? No, pi r squared. Okay, so the d will be actually equal to slope divided by many things. And you need to find the derivatives, right?
Yes, now we have in the denominator r squared, and I'm not entirely sure how we can find the derivative of the denominator when it's squared.
I hear you. So how do we find the derivative of constant over x squared? Okay, let me create some space because it's stupid to write on words. Okay, so I'll move this. Okay, so back to here, what is the derivative of a constant over x squared? This is your actual question, right?
Yep.
Okay, isn't it k times x to the power of -2? Right? Isn't it minus 2k x to the power of -3? Can't, right? Am I right? So you simply have to do -1. And I can write this as minus 2k, and you're right, this is a bit awkward, x to the cube, because negative means denominator. Am I right? So every time you have k over or any constant, in this case, the constant is slope divided by g pi. That's the constant. You put it aside, and 1 over r squared is going to be -2 over r cubed. Okay, if you want to take a screenshot of what's happening right now. Now for the derivative of the slope, it's 1 over whatever you have. Pi is a constant, it's not a measurement, so no need to worry about it. And g is basically in the denominator. The derivative of constant over x is minus constant over x squared, right? Okay, any other questions related to lab 7 before we start the actual lab 4?
Thank you so much.
All right.
دكتور أنا عندي بس هيك سؤال صغير بس بخصوص هنلاقي البوينت فورس بأول تيبل.
Yes.
هو البوينت فورس بناخده هون equal للapparent weight؟
Actually, no. The buoyant force that I'm gonna call F is equal to the real weight minus the apparent weight. And the real weight can be found when the depth is 0. I don't remember what results I gave you, but when the depth was 0, whatever value, let's say you have 20 newtons. And let's say the depth is 1, I don't know which unit, and it's gonna be, okay, so this is not buoyant force, this is the apparent weight, or whatever the force sensor is giving you, it's gonna decrease 19. So you say the buoyant force here is 0, and the buoyant force here is 1, because it's the real weight minus the apparent weight. It has to be linear, so the depth is gonna go 0, 1, 2, 3, 4, 5, and this is the force is gonna go 0, then increasing. You know,
yes,
so you should get this. If you get something opposite, it means you're plotting the apparent weight and not the buoyant force. So it's the real weight minus the apparent weight, and your force sensor is measuring the apparent weight or the fake weight. And the real weight, how do you find it? It's the first measurement, because your cylinder, it's still outside the water, so it's the real weight. The confusion was done on purpose to you. We want to confuse you to make sure you get the idea. Okay, so if you're confused, that's great. And if you're not confused anymore, that's great also. Any questions related to lab 7? Yeah, I suppose your silence means you're fine. Now let me tell you a bit our schedule. So we're done with 1, 2, 3, 4, 5, and 7. Now it's time to do, and I promised to go on campus to do lab 4. So here it is, lab 4 is ready for us. Lab 4 is easy. It's about momentum and collision, and I suppose you started that in the course. So how's the outline? I'm going to start discussing what linear momentum is, something that supposedly you know from high school. Did you start this in the course? I think yes, but a confirmation from, yeah. All right, so, and then we need to discuss the impulse momentum theorem. I know that the title states collision, but what I care about in the collision is not the conservation of linear momentum, the thing that you do in the course. I care about how the impulse is related to the force applied during collision and therefore the time of the collision, all right? So force and time are my main interest. I'm gonna discuss the experiment. It's not difficult, and the sensors and equipment are basically something not new to you, except the force sensor. Those are applications, the airbag and the egg drop contest, because some questions were asked in the lab report about those, and I thought it's a bit confusing for students, so why not discuss them in the live session? And wrap up by discussing abrupt versus cushioned collisions, okay? In general, what is linear momentum? 17 participants, I'm gonna remove this. So linear momentum is basically a quantity that is needed. Why is it needed? I know it's related to mass and speed and velocity, to be honest, exactly like the kinetic energy. However, the momentum is important because it is transferred totally between objects upon collision, and that's why we're interested in it. All right, it's a vector quantity, it's not a scalar quantity like the kinetic energy. It is simply the mass times the velocity. So if the velocity has a direction to the north, the momentum, by the way, bold means vector, so the momentum is going to be to the north. The unit of momentum is, anybody remembers, knows anything about the unit of the linear momentum? I hear you.
مش kilograms per meters per second.
Exactly, it's kilograms dot meter per second, exactly like mass times velocity. All right, so that's the direct definition. Now, to discuss the impulse momentum theorem, you need to be aware of the fact that it's nothing but Newton's second law. Who remembers Newton's second law? Of course, everybody does. What is Newton's second law?
Mass times acceleration.
Who is mass times?
Equal.
Yes, the net force is mass times acceleration. So if I start my statement with net force is equal to m times a, I can simply replace, and by the way, that's a vector equation, definitely you know this. I can simply replace a by the derivative of b with respect to time, okay? And I can simply put the mass inside, so I would have dp over dt, p being the linear momentum. If the change in linear momentum is constant, like it's a linear increase, and you know for a fact that most of the problems you cover in this course is a linear increase in acceleration, in other words, in velocity. In other words, your acceleration is constant. Am I right? All the problems you cover are constant acceleration. We usually don't have a change in the acceleration unless for special cases. I can replace dp over dt by delta p over delta p. All right, so F equals ma will end up being F equals delta p over delta t. This is the impulse momentum theorem that can be written like that as well. Now the question is, how do I find delta p? And another question is, how do I find F net dot delta t? So the net force sometimes is given to you. Delta t, you have to be careful. It's the time of the collision, and most of the collisions are done abruptly. So the time is a fraction of a second. It's not the time before the collision, neither the time after the collision. It's the time of the quick collision, which is a fraction of a second, and I'm gonna show you exactly delta t for our experiment. Now delta p can be calculated by doing mv in final minus mv initial, or by doing p final minus p initial. Okay, I'm gonna go back to this in a moment. So this is the impulse momentum theorem. Okay, this is it. Now the experiment, you will be given a track, and I can switch to the video in a moment. The track, you will be using two sensors, the motion sensor, and you already know it. Anybody remembers how the motion sensor works? I hear you. Anything you remember? User-friendly, not? What does it send? What does it receive? What does it measure? What does it give eventually on Data Studio?
Motion sensor قصدك?
Yes, motion sensor. How the? All right. So it says it comes with a screen. Sarah, no, it does not come with a screen, but yes, it is connected to the computer. So you have an app or a software you can use to see something digital. Gives curves, you mean plot? Yeah, so the curves of what? Which curves does it give? Using a motion sensor, I can see some plots. What kind of plots? V versus time, yes. Other than the X versus T, A versus T, and that's it. So the motion sensor would measure the position of the object, and Data Studio can give you an XT graph, a VT graph, an AT graph. Now the question is, how does it function? Anybody remembers anything about the functioning of the motion sensor? Is it thermal functioning? Does it feel the thermal waves of an object? How does it function? Does it measure voltage? What does it measure? Nobody remembers? I'm a bad teacher. All right, so the motion sensor will send ultrasounds. Yes, thank you, Ellie. And those waves, they are sound waves that we cannot hear. They got reflected back, and the Data Studio, along with the motion sensor, can measure the time. Exactly, thank you, Ellie. The time taken for the wave to come back. Knowing the time and the speed of the wave, because it's known, you can tell the position of the object. Now, position is changing, you can find V. V is changing, you can find A by simple calculation. So Data Studio is actually doing the calculations for us. Now the force sensor is a new sensor. The force sensor is not user-friendly, and no, we don't like it. It's very sensitive. It needs calibration. It does not measure force, it measures voltage. There's a capacitor inside. So calibration means I need to give the force sensor a known force, measure the voltage, and then type inside Data Studio, this voltage is equal to this amount of Newton. Now, Data Studio, you do the calculation to estimate the forces measured by the force sensor. This is one issue. Another issue is you have to zero the force sensor. It has a zero button after every single measurement or before every single measurement, okay? But it's okay, we're gonna use it. The motion sensor is here. It's gonna look at your cart, and you have a force sensor just before collision is gonna happen. So the cart is gonna slide down, it will hit the force sensor. The force sensor will measure the force and definitely the time during which collision was taking place, and the motion sensor can calculate the V. I will show you, this is a force sensor that is not similar to what we have, but it's also from Pasco, and it will also give us the same results. This is our actual lab. This is in the morning. So this is the force sensor. This is a protractor. I want the angle to be constant. I will not change the angle throughout the experiment. I will just make sure it's constant. And this is the force sensor in here. It has a bumper. You see the bumper. And the cart has something elastic in here. It will hit the bumper. And the force sensor can measure the force. FDT will be measured by the force sensor. So this is measured by the force sensor. I hate this color. And MV final minus MV initial, or to be specific, V final and V initial will be measured by the motion sensor. So motion sensor will give me a VT graph, force sensor will give me an FT graph, something like that. Okay, so as the cart is sliding down the incline, so again, I have an incline with a certain angle, the speed starts increasing from 0, and then suddenly you have collision, a sudden change from positive velocity to a negative velocity. And then as the cart is moving up the incline, it's gonna slow down to a stop. I will start recording when I release the cart and stop recording few seconds after the collision. By the way, I set sudden change in the sign of the velocity. It's not really sudden. If you look at the time interval, it is of a certain length, which is not 0, but so tiny. On the force sensor, you will see 0 force and then sudden increase and then nothing. The sudden increase is not so sudden because the time interval is not actually 0, even though it's so small. How do I find FDT? F is not a constant for me to do an actual F times an actual delta T. I will take the area under the curve. So I'm gonna find area under the curve. The software does the work for me. And you can see the area in purple, and you can read the area here. 1 second, I'm sorry, this is slow. My baby connection. All right, so area, you see, it will give you the area, and the unit is Newton.second, which is the unit of the impulse. So back to the impulse. So this is the impulse, it will be the area under the curve. On the other hand, you take this point, and you can find the coordinates of this point. The y component is v initial, and the coordinates of this point, only the ordinate is the v final. All right, the y component is v final. So with the SMART tool, you can measure v initial and v final, which is v just before collision and v just after collision. The mass is known, your system, it's gonna be given to you. So your job is to do mv final minus mv initial, and to do the area under the curve and to compare them. But here, be careful, you're comparing two experimental values, and then you will ask me, how do I compare? I find the percentage difference. And usually when we find the percentage difference, what do? We do theoretical minus experimental over theoretical. Here, both are experimental and supposedly very close to each other. So you're gonna do experimental 1 minus experimental 2 over one of them, and it shouldn't really matter if they're very, very close to each other. So take any to be your reference and compare with respect to it, okay? All right, so now let me show you the real graphs. This is my VT graph. You see it's an increase, then you have a collision, then you have a decrease in speed. You can see the coordinates of the point. This is the time, and this is the velocity. Yes, the velocity is negative. So when you do V final minus V initial, it's gonna be negative value minus a positive value. So you'll end up adding them in a way. Think about it. The VT graph is negative. I mean the FT graph, this is F versus time. It's negative because for the hour force sensor, a push force is a negative force, which is okay because this side of the equation will give you negative, and negative, remember, is only a direction. It will be to the right if you want. And the area on the curve will be negative, so fair enough. The area is written here, and it will be more visible on the video. All right. Before I start this, probably let me show you the table you need to fill before I show you the actual videos. The mass will be given to you. You should add a mass to your cart for each trial. So initially with no extra mass, then you add a small mass, then you add a big mass, then you add them both, and then you add probably 2 big masses. The impulse is basically the area under the curve. So this is the area under the curve. V before and V after will be given to you through the VT graph. P before should be calculated. So you do mass times V. P after, you do mass times V after. Delta P is the difference. And then percentage difference should be done between delta P and the impulse. All right, those two should be compared and they should be close to each other. And yes, they're both experimental values. Nothing is theoretical here. Nothing. I have no reference. I cannot tell what the speed is theoretically, unless you want to measure height and do conservation of mechanical energy and find the speed. But no, we don't have enough data to do this, but it sounds interesting. Before I discuss the egg drop contest, do you have any questions? Is it confusing? Let me show you on fast forward the videos, okay, to make more sense. I don't know which one comes first. I can guess this one. Yes, the videos were done by our lab supervisor. I mean, she took the recording and I was doing the experiment. So I asked her to help me because I know my old videos were not that good. And you can see it's wide and big as you requested, and I can make them bigger for you. It's also not on tripod, so the video is kind of, the camera is kind of moving, which is bad anyway, but also good because we can zoom into while I talk. I don't know if you're gonna like it, but it's a good thing to try. So basically here I'm explaining what the thing is. I took my time explaining the setup because I believe this is what's important for you, the setup and the uncertainties on the setup. This is the motion sensor. I know you know it, but it's always good to remember what it is about and what it does. You see the zoom in. Okay, I'm explaining a bit the friction on the track. I'm showing you the angle indicator, explaining that this one should be a constant and you can see the uncertainties. I'm explaining how I vary the height and explaining also that the height should not vary. So I'm gonna pick a height and make it constant. How do I know the height is constant? I don't really care about the height. I care about the angle being constant, because acceleration g sine theta is what I want to be a constant. Because why add variables? If we have more constants, you can focus on your only variable, which is the mass, if I'm not wrong. So this is the card. You can see the mass, and I'm saying this is a digital measuring tool. And I love the fact that our supervisor zoomed in for you to see well. And I'm explaining the collision here, explaining that this guy should be aligned with the bumper. And then I moved on to show you how the connections are done. And this is the force sensor. This is the first time you see it. I'm explaining the fact why I use a bumper, and sometimes we can use a hook, and how calibration is done. And I'm showing you the tear button, or the button I need to push every time I need to take the measurement. You can definitely listen to the video when I send you the link. So this is the tear button, or the button I need to push to zero the instrument for every trial. Like here we have 1, 2, 3, 4, 5 trials, like 5 times. Okay, and here I'll put it back, and here it's gonna collide, and make sure it's aligned, because sometimes the students don't see the alignment, and sometimes the force sensor زيها هيك وthe cart زيها. So alignment is very important for you to have the real measurement of force. All right, so I'm explaining a bit the collision without show. And I'm also explaining that I hold the track a bit, otherwise it's gonna slide and the angle is gonna vary. If the angle varies, no sources of errors, no problem. But it's easier to analyze your values if you have a lot of constants. You will see the variables, but no, it will not affect the percentage difference, because V final, V initial will always change your area under the curve. Okay, so that's it for the first video. I'm gonna stitch the videos together. Now the experiment, let me go back to first. I will start the experiment now. I will show you the first measurement. Okay, so I'm gonna release the cards, and you see the mouse and the wire of the mouse, it's under the track, because I don't wanna have my arm as an obstacle for the motion. This is sometimes a challenge. So I'm gonna get ready and click record as I release the card. شفتوا? I make sure the track is well held, otherwise it's gonna slide. The collision is strong, you know, like a boof collision. You can see it. Okay. So I clicked. All right, it wasn't very strong because the angle I picked is small, like 6 degrees. But if you pick an angle bigger than 10, it's gonna be really fast, and sometimes the cart will fall down out of the track, and we don't want this to happen. So, but yes, I can show you probably in the first video how the track is gonna slide if I don't hold it well. So if I continue now, you can see, all right, this is well zoomed in. You can see the VT graph and the FT graph. I will explain each again, showing you the smart tool and how I can manage to put the smart tool on the first peak and then on the second peak, and how I can read time 1, time 2, and find delta t if needed, although it's not needed, and how to find the y-intercept for the before and after the collision. And also I can show you the FT graph. I zoomed a bit on the x-axis for you to see it. I'm very proud of the 0 before collision, because this shows that I zeroed my sensor well during collision, and then you have 0 again. This is the area under the curve. It's not visible, but you can see the gray hatched area. Oh, it is visible, negative 0.25 Newton second. All right. And here I'm showing you that I added an extra mass. I don't know if it's visible. This is an extra mass I'm adding to my system. You can see it here again. Experiment for different masses. I will add an extra mass to my system. I will keep everything as fixed, the angle fixed. All right, so everything will be constant. Add mass and see what will happen. I did a quick trial to show you what happens. I got something like in singularity, I think that an error in the experiment, and probably the area under the curve was stronger or not. It jumped from 0 point something to 28, I think. All right, did I face any errors? No, the only like singularity, if you look well at the graph, it looks weird. Look. Yeah, you can see the area under the curve. Okay, you see this? That's a big peak. Let me decrease the peak a bit. Okay, I don't know what's happening here. It could be a source of error. All right, the source of error could be due to the fact that as the cart, let me show you, as the cart was hitting the motion, the force sensor, probably the force sensor moved to the right a bit. All right, because it's a sudden increase, like something moved a bit out of the track. Probably the mass is not well centered. Probably the mass is moving on the cart, you know, because upon collision, it could be due to inertia, or to the collision itself, the mass has moved and created the singularity. Usually students face errors because of the fact that the force sensor is not zeroed well. It's not a mistake, they zero the force sensor, بس هو بيسطل الforce sensor. That's why we ask them to zero and to keep the finger on the zero for 10 seconds to make sure it's zero. The errors they face is if the cart moves out of the track. Usually the force sensor has a limited precision, the motion sensor has a limited precision. The mass written on the cart was measured using a balance that has a limited precision. So these are sources of, and definitely friction. All right, yes, so I'm trying to list the sources of errors. And that's it. That's it for the experiment. Like, I'm gonna repeat the same exact thing for 5 trials, and that's it. Now, if you're okay with the procedure, we can discuss a bit the egg drop contest. What is the egg drop contest? It's a big competition that happens in old schools, departments around the world. It's famous. You can Google it, you can find it on YouTube. The question is, you have a raw egg and you need to throw your raw egg from a certain height and it should not break. So therefore you need to protect it. How do you protect it? You make sure the force of the collision is small. And how do you do that? For you to decrease F, you need to make sure that delta P is small. Delta P meaning the velocity before the collision is small. In other words, you make sure the egg will fall down on the floor slowly, and a parachute system will help with that. You can see the guy, you can see a bag, plastic bag. This would help the system or the design or whatever you want to call it to fall down slowly. So P before collision, you can control it. P after collision is 0 because collision, it will stop on the floor. You can also increase delta T. Now I'm gonna ask you, how would you increase delta T, which is the time of the collision? Any idea? How do you create a collision with a long time of collision? I hear you. So the question again is for you. Collision. You want the time of the collision to increase. Priscilla, the height is a constant. All the students should compete, let's say, from a height of 10 meters or 3 floors. Low velocity will change delta P. It will not affect the time. Remember, time of the collision. Like it's gonna touch the floor through 0.2 seconds or 0.4 seconds while touching the floor. Sponge, can you please elaborate, Fadi? Rubber. How is that? Where do you put the sponge? The rubber, what do you mean? Okay, something like knees to bend upon impact. Ya Rabbi Fadi, look at you, so creative. You're gonna create artificial knees for the egg. Sounds so funny. Something elastic for the collision. Yes, Fadi. So probably surround your egg with a sponge or something. Yes, I know Eli talked about the knees. That's true. So those straws probably would work as knees. They're empty from the inside. Probably they're gonna bend a bit. Eli, why the sad face? I said you were very creative. All right, anyway, the funny thing about this experiment or competition is how creative students can go. So basically, they can make sure, by the way, to decrease delta P and to increase delta T, this or that or both. And you can see that, by the way, this was done at LAU like 5 years ago. It was the engineering department and a lot of students. I think the sponsor was Red Bull, and they had a very high, what do I call it? Platform. I'm talking more than 20 meters. It was funny, and it was like a big party on campus. It was loud with music. and probably the person who won had the egg inside an eggplant. I don't know, I don't remember actually. No, probably I'm wrong because this sounds very silly. I don't know, but anyway, students were so creative. Yes, and we had egg yolk all over the place. All right, anyway, so make sure you understand that the time of the impact is very important because it decreases the force, and this is what safety is about. The same thing for the airbag. Anybody can explain how the airbag would work if I consider the impulse momentum theorem? What does it do to my system, to my body? How does it protect me? The airbag, I'm talking about the airbag. Anybody would like to say something about it? How does it take my momentum? Momentum before collision is my speed times the mass of the car. Momentum after the collision is 0. And both ways, Andrew, I have no choice. It was a surprise car accident. I can slow down before the actual accident if I have a good reaction time, but the accident happened. Airbag has nothing to do with my speed. The airbag cannot change my speed. It's only my brain who would give me a reaction to say slow down before the accident. So no, Andrew, the airbag will not affect my speed. It will only increase, Karel, the time of the collision. So it is an increase in the time, Karel. Can you explain how? Yes, how does it increase? In other words, my head is not gonna stop suddenly. It's gonna take time through the empty bag to stop, so more time. And you can see time is in the denominator, so which means more time means less force, and less force means safer. Andrew, by the way, takes your momentum. This is a common answer. All the students would say that. And in other words, what you said, Andrew, is not totally wrong, because in other words, it's like removing your momentum or changing your momentum during a longer time. So the ratio of momentum over time is going to be small. So probably what you said would make sense in a way. All right. So I really stress on this one because it's very important for you to understand. Time of the impact is very important. Now, if I try to compare abrupt versus cushioned, abrupt is when the time is small and cushioned when the time is big. And going back to the equation, F is equal to delta P over delta T. I don't know which one I'm going to use, if this equation or the other equation, which is delta P equals to F delta T. Basically, I know it's the same equation. All right. So we know that F delta T is the area under the curve. It's like we're saying delta P I cannot control, right? Because delta P is P final minus P initial. P final is 0 after the car accident. Priscilla, what's wrong? You're talking about which question? You're fine? All right. So my statement, all right. So abrupt collision is when the time of the collision is small. Cushioned collision is when you have cushioning and it takes more time to stop. And by the way, the delta T is the time during the collision. Yani. Anyway, it's below 1 second. Okay, so when I say delta P is F delta T, delta P is assuming to be constant because cushioned or not, the force before collision, I mean the velocity before collision is not affected. And after the collision, it's gonna be 0 and mass is a constant anyway. All right, so delta P is the constant and delta P means the area, isn't it? So in other words, this graph and this graph should have the same area. Right? Same area. But the difference is this one has a bigger time and this one has a smaller time. And you can see the bigger the time, the smaller the force. So this is the maximum force. And the smaller the time, the bigger the force. They're inversely proportional. No, I'm talking about one system going into the wall, Andrew. The car, before collision, it's gonna have a certain mass. After collision, it's gonna have the same mass. So I'm talking about one system hitting a wall, all right? Or one egg hitting the floor. I'm not talking about collision where two objects are bouncing. Yes, and same thing with the airbag. The airbag will increase your time and it will decrease the force. So your graph is gonna look like this. This is with airbag, less force and bigger time. Without the airbag, it's gonna be very sharp and very strong in force. So it's gonna be very dangerous for you. All right. So yes, it's also about the airbag. So without airbag, it's gonna be, the graph is gonna be so narrow and so dangerous because very high force. With the airbag, it's gonna be very wide and the force is gonna be low, which is safer for you. Okay. I think this part was confusing because I did not introduce it well. Yes, so it's a game between time and force. The bigger the time, the smaller the force. And yes, you can say they are inversely proportional. What do you mean it's not only about the time, the airbag? Does it do anything else?
It could be a better landing, more cushioned landing than مثلا انت جيتي خبطتي بالسياره فرد مره.
Okay, so what is more cushioned landing? Isn't it giving you more time to land?
لا, it's giving you a surface that's easier to let's say take the impact from. إذا أنا جيت خبطت بصخرة غير ما أخبط بمخدة مثلا.
شو الفرق بين الصخرة والمخدة؟
إنه الصخرة وقت تضربي فيها it's a hard surface, so in the same second actually لا معك. واو. اوكي مبلا التايم هو الفرق موجود.
بس تعرف لفت لي نظري على شيء. شو الفرق بين صخرة عريضة وصخرة كتير مروسة؟ like a very sharp edge.
إنه العريضة it has okay more surface but not time يمكن كمان معها.
I think both they have a very sharp time, a small time, but the area probably would give you like sometimes when the force is on one spot, the pressure is higher because you know pressure is force over area. So probably you can create an appendix to your analysis and discuss a bit pressure. Yes, thank you, Fadi, for saying pressure. But eventually the force is what makes it dangerous or not. You're gonna be in danger zone anyway. When we're talking about sakhra, اللي هي a very abrupt surface, you know? Yes, so...
The bigger one will give you less force because there's less pressure than the mrawsi.
All right, let's not confuse this. So basically, let's think about the following. Delta P is constant, mass is a constant, with speed, we know what it is. Now, delta T will affect the force. Talking about if pressure is actually extra. Because who said higher pressure will be more dangerous? Probably higher pressure will be more dangerous on only a part of your face. You're gonna lose an eye, but save your body. Probably. I know this sounds so violent. I'm sorry for that. But talking about the pressure is really related to each case in itself, you know? So that's why talking about the surface depends on the actual example you're taking into account. But talking about force in general is a very meaningful because it will really discuss safety. All right. And thank you, Andrew, for giving me this example discussing the surface itself. So back to our abrupt and cushioned collision, it's about timing. And usually the students would think that time is how long before you hit, which is wrong. It's how long during the collision. I know that during the collision, time is very small. We're comparing a fraction of a second to a fraction of a second. The human mind would think that it's a very small time. However, this small time can increase a bit to put you in the safety zone. And this is very important, okay? Anyway, so probably I can show you the lab report a bit. Just for you to be aware of the fact that data analysis is very not like very narrow, for you to be at least less worried. Okay, by the way, this is the diagram. This is very not informative because this is gonna hit the force sensor, which doesn't have a hook, it has a bumper, and this should be at a certain angle because you're not gonna push it by hand. If you give it a certain angle, you will make sure it's the same initial speed all the time. Initial speed meaning before the collision. Anyway, I wanted to show you this question comes before the experiment, so it's a general question talking about the egg drop, I think. And those are the questions: why, compare, and whatnot. Nothing data analysis. And you can see no percentage, no uncertainties needed, only percentage difference and some analysis questions, which means the lab report will not take you a lot of time. Try to do it with no help. Try to collaborate with your partner only. And let it be a good practice for you before any midterm, because doing your lab reports very well will make you study less for a midterm and a final exam eventually. Okay, if you need help throughout, yes, I'm sorry for that. It was long and it has a lot of data analysis, but not all lab reports are like that, Tiara, and thank God for this. No, this is not part of the midterm. The midterm is only the first 4, lab 1, 2, 3, and 5. Okay, and all the other lab reports will be for the final exam. Any question? That's it for today. Why not, Andrew? As you can see, I'm not running into giving you results. Every time I give myself a day or two, and I'm pushing a bit the deadlines. I just want to make sure not to give you 2 lab reports in 1 week eventually. Yes, I can push it few days, probably 2 days if you want. I will try to be reasonable. I will see how much time I have between this lab and the next lab and find the mean in a way. Okay. The thing that is helping me that you are way ahead of the Tuesday section. But remember, eventually you have a day off around Easter Monday somewhere. So eventually you're gonna be late at some point. So yeah. Any question? I'm gonna stop recording, but I will stay here for you.